Hi students, welcome to the class. In today's class, I will solve a question which is asked in 2020, JEE Advanced 2020 on the first unit of class 11. And the question is from dimension and analysis. And by the way, from unit 1 of class 11, there is only one question in JEE Advanced 2020. And the question is from paper 1. The question is, sometimes it is convenient to construct a system of units so that all quantities can be expressed in terms of only one physical quantity. In one such system, dimensions of different quantities are given in terms of a quantity x as follows. It is given position has the dimension x to the power alpha, dimension of speed x to the power beta, dimension of acceleration x to the power p, dimension of linear momentum x to the power q, and dimension of force as x to the power r. Then you have to find out of these four given options, which options are correct options. So let us try to find what are the correct options. So let us see if this option is correct or not. First option, alpha plus b equal to 2 beta. For that, see, we have position as x to the power alpha and acceleration as x to the power p, and we need alpha and b, so we will multiply position, dimension of position with dimension of acceleration. So if we multiply dimension of position with dimension of acceleration, then we know dimension of position in terms of fundamental physical quantities. If we can write, then it is L1 and acceleration is L1 t minus 2. Then it is nothing but L2 t minus 2, and we can write L2 t minus 2 as L1 t minus 1 or 2. And what is L1 t minus 1? This is nothing but speed, right? Then position is x to the power alpha, acceleration is x to the power p, and speed is given x to the power beta and to the power 2. Then this is nothing but x to the power alpha plus p, and this is x to the power 2 beta. So we can write alpha plus p equal to 2 beta. So we see that the option A is a correct option. Now let's see if option B is correct or not. If option B is a correct option or not. See, in option B it is given P plus Q minus R. So what I will do, acceleration times Q is linear momentum, and this is minus R, so we will write force here. Now see, what is acceleration? L1 t minus 2. What is linear momentum? M1 L1 t minus 1, and force is M1 L1 t minus 2. Then what will be the dimension? It will be M1, so this cancel, M0, and this is L1, then there is only L1, and how many T1? T2 minus T minus 2, T minus 2 1, then it is T minus 1. So this is nothing but dimension of speed. Then acceleration is Now we can write acceleration is x to the power p, linear momentum as x to the power q, and force is x to the power r, and speed is x to the power beta. So it will be x to the power p plus q minus r, and it will be x to the power beta. So finally we can write p plus q minus r equal to beta. So yes, option B is also a correct option. Now let us see if option C and D are correct options or not. Now see, this is P minus Q plus R. So what we will write, this is P, so P corresponds to acceleration, then this is again Q, but Q is minus Q, so I will write it here, and this Q corresponds to linear momentum, so I will write linear momentum here, and this is PQR, and R is corresponds to force, so I will write force here. Then not only this thing, acceleration is L1 t minus 2, force is M1 L1 t minus 2, and what is linear momentum? M1 L1 t minus 1, right? Acceleration, force, and linear momentum. Now M1 M1 1, L1 L1 1, there is only L1 left, and t minus 2 t minus 2 t minus 4, and it will be about t plus 1, then it will be t minus 3, and this is L1 t minus 3, and L1 I don't know what is L1 t minus 3. This is length per time cube, so I don't know any physical quantity which is length per time cube. So and by the way, length per time cube is not position, not speed, not linear momentum, and not force. So I cannot express this particular dimension in terms of x to the power something. So I don't know what is x to the power something. By the way, this one is, see, x to the power acceleration means x to the power p, force is x to the power r, and linear momentum is x to the power q. And I don't know what is this quantity. What is x to the power what? I don't know what is x to the power this thing. And this thing I think x to the power p, then it will be p minus q plus r, and I don't know what is x to the power something. And surely this something is not alpha, because alpha is a position, so it should be x. If it is alpha, then it should be position, and it should be L1. If it was L1, then I can write it x to the power alpha, and if I can write x to the power alpha, then only p minus q plus r will be alpha. And by the way, this is not position. I don't know what is that quantity. So surely the option C is not a correct option. This option is wrong. And let's see the last one. P plus q plus r is beta or not? Of course, p plus q plus r will not be beta, because we have seen p plus q minus r was beta. So p plus q plus r is definitely not beta, because it was this p was acceleration, then force. No, acceleration, then linear momentum, then force. So acceleration times linear momentum by force. Acceleration times linear momentum by force was speed. So acceleration times linear momentum times force cannot be speed. So the option D is also wrong. Okay. Okay. Thank you.